Okay, how are you guys? This is chemistry time, and today we are dealing with acid, bases, and salt. Acid, bases, and salts. Okay, so we need to define each and every term. Okay, each and every term. We start with acid. How do you define acid? What is an acid? Okay, so different books, they will give you different definitions to do with the definition for an acid. But I'll give you just few of them. Number one, the simplest one, you just say it is a proton donor. Okay, so an acid is a proton donor, which means that all acids, they are positively charged. So which means that they will try to donate this positively charged to something else so that the salt can be what? Can be produced. So we usually say that acid, they are proton donors in nature. Okay, so that's the definition, the first definition for an acid. Okay, now we can also define an acid, because if you look at this one, if you look at this general equation, acid plus base, it will give you salt plus water. Okay, those are the things that you are expecting to be produced in that reaction. So we can define an acid as a substance, a compound that reacts with a base to produce salt and water only. Okay, so we are saying it is a substance or a compound, you may call it, that reacts with a base to produce salt and water only. Okay, so that is exactly what we call an acid. Okay, now these acids, they are in classes and in types. So let us talk about classes of acids. The first class, it is called mineral. Mineral. Aye. Mineral, like this, huh? Mineral acids. Okay, so apart from this, we have what we call organic acids. These are two classes of acids. These are two classes of acids. Now, what are they? What is amino acid? Okay, amino acid, these are acids present in minerals. Okay, in minerals. Then organic acids are acids present in organic substances such as fruits. organic substances, e.g. fruits. Okay. So now we know what amino acids are and organic acids. Now these acids, they are also in types, 2 types. Types of acids. So we are expecting an acid to be either strong acid or weak acid. So acid can either be strong or weak depending upon the nature of acid. But you need to understand to say, oh, amino acids are strong acid. All amino acids are strong acids, and all organic acids are weak acids. Okay, hope you have understood that one. Weak acids, all organic acids, they are called weak acid. But we need to understand the science behind strong and weak. Why do we call them strong and why do we call them weak acids? Okay, so let us start with strong acids. So strong acids, these are acids that ionizes completely in water. Ag, okay, hydrochloric acid. It will ionize completely in water. So positive, then plus chlorine negative. Okay. So you have seen that it is ionizing completely. Okay, so we are saying these are acids that ionize completely in water. Let us talk about weak acids. So automatic weak acids, they will be the opposite of strong acids. So these are acids that do not ionize completely in water. Okay. Example, we can talk about organic acids like carboxylic acid, okay, and many others. Then, apart from this, let us talk about what we call basicity of an acid. What is basicity of an acid? Basicity of an acid, it is the number of hydrogen ions that are produced per molecule of an acid. I repeat, it is the number of hydrogen ions produced per molecule of an acid. It is the number of hydrogen ions produced per unit of per molecule of an acid, Okay, so that's a definition of what we call basicity of an acid. Okay, so now let us look at example of basicity. Examples. Example 1. Okay, what is the basicity? Or let me just write it this way. Find the basicity of the following acids. Number 1, hydrochloric acid. Number 2, hydrochloric acid. Number 1. Number 2, sulfuric acid. Number 3, phosphoric acid. Okay, I think these are enough. Okay, so what is the basicity for the following acids? Number 1, hydrochloric acid. Now, when it undergoes ionization, ions will be produced. Okay? Ionization. Okay, then ions will be produced, which is hydrogen ions and chloride ions. So, when we look at this one here, you realize there is a 1 in there, okay, and a positive there. So, which means that the basicity of this acid is 1. So, the basicity is 1. That is the basicity of an acid called the hydrochloric acid. Number 2, we have sulfuric acid. If it undergoes again the same process ionization, the ions are produced, which will give us 2. Please, when you light when it undergoes ionization, this 2 becomes a whole number, then a positive there, then plus a sulfate, it is a radical, so it will be negative there, like that. So if you look at this one here, there is a 2 and a plus. Okay, 1. So a plus 1. So this time C plus 1, we get a plus 2. So in other way, the basicity of this acid is equal to 2. Number 3, phosphoric acid. Same process, 3 there, positive, then phosphate, which is a radical, negative 3. Okay, so 3 times positive 1, we get positive 3. So the basicity of this acid is 3. Okay, hope you have understood how to find the basicity of an acid. Okay, so next we talk about now the characteristics of an acid. The characteristics of an acid. Now, the characteristics of an acid, of course, we can talk about another word that they can use for this. It can be the properties. Okay, so we can have chemical and physical properties, but in most cases they like asking, okay, in general. So the first property of an acid is that it tastes sour. Okay, so it tastes sour. That is the first one. Then number two, if we can put it on what we call a pH scale, you realize it has pH value less than 7. So if it is an acid, then we are expecting the pH value of that particular substance to be less than 7. Okay. Acids, they react, so it reacts with a base to produce salt and water. That's it. Then apart from this, other characteristics of acids is that they also react, it reacts with a metal to form salt, and hydrogen gas is also produced, and hydrogen gas is produced. Okay, acids, they, or let me use the word, it has positive hydrogen ions. Okay, you can simply see what we are doing here when we are finding what we call the basicity. You realize that in each acid you are expecting to find the hydrogen ions like that. So which means that for us to know this is an acid, this one should be true. Okay, so it is a property or the characteristic of an acid. Okay, then apart from that, an acid can react with metal carbonate to produce three things: salt, water, and carbon dioxide is also produced. So guys, let me write the last one that I've remembered. Okay, they turn, or it turns lead litmus paper, it turns blue litmus paper lead. But what if it is lead litmus paper? It remains unchanged. Okay, so if it is a lead litmus paper, it remains lead. It doesn't turn, just not to say it is an acid. So these are the properties or characteristics of acids. Okay, so let me also try to speak something to do with pH scale. Okay, for your sake. A pH scale, pH stands for potential of hydrogen. Okay, potential of hydrogen. The potential of hydrogen, since it is the one that determines whether it is acidic or what. Then it runs from 0 up to 14. That's a scale. So 7, it is at the middle. So 1, 2, 3, 4, 5, 6. Okay, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so now, remember we are having two things, bases and acids. So all bases, they are having pH value greater than what? 7. They are here. Base. I've not yet decided talking about this one, but I'll talk about it. You need to know before that time that they are that side. Then acids, all acids are here. Now, since the acid can be strong and weak acid, so those which are weak acid, they are between 1, or let me say between 0, which is, but the best one, it is 1. Okay, 1 to somewhere 3. Okay, 1 to somewhere 3. These are strong acids. So weak acid are from 3 to 6 weak acids. Okay, hope you have understood. Okay, to do with the pH scale. Okay, when I'll talk more about bases when I've explained what a base is and so on, to do with the base. But as at now, just know to say the bases are this side of the pH scale. Okay, so next, let us talk about the base. The base. How do you define a base? If acid, it is a proton donor, then this one should accept. So it is called, it is a proton acceptor. Okay, it is a proton acceptor, or we define it as it is a substance that has hydroxide as its only negative ion as its only negative ion. Okay, so you need to understand that one. Okay, so just like I told you, it has a lot of these things. They have many definitions. I've remembered one which we also use under oxides. It is Na. It is Na oxide of a metal. Which means as long as it is a metal and it has oxygen attached to it, that one, it is a base, my friend. Okay, now these bases, they are divided into two. Okay, they are divided into two. So base, this base can be either insoluble base or soluble base. When you are talking about insoluble bases, they are solid in nature. Okay, then this one here, it is a base that it has dissolved in water. Okay, it is a base that has dissolved in water. So it is also given a special name which is called an alkali. It is given a name called an alkali. Okay, so we are saying an alkali, it is a dissolved base or soluble what? Base. So that's how you define what we call an alkali. And in most cases they have hydroxide in them. Okay, they have hydroxide in them. Okay, so we have now understood to say base or bases, they are divided into two, which is insoluble bases and insoluble bases. Examples of this, okay, we have magnesium oxide. All oxides of the metal, they are solid in nature, they are insoluble in nature. Sodium oxide, okay, sodium oxide, it is insoluble. But when you are talking about now this one here, we talk about like sodium hydroxide, okay, calcium hydroxide. These are some of the examples of what we call alkali or soluble base. Okay, now that we have this knowledge, let us look at the characteristics of a base. But before we look at the characteristic of the base, we need to understand to say a base can also be strong. We have what we call strong bases and weak bases. So strong bases, they are those which ionizes completely, then those they do not. Okay, the opposite. And on the or in other words, we can say bases, these, strong bases are those having the pH value which is greater than maybe 12 or 13. Let me say greater than 11.